All right, this lecture is going to get you moving into air masses. We're going to be able to explain what an air mass is. We'll be able to describe how air masses are classified, and we'll describe the general weather associated with each type of air mass. Now, you'll see in the United States, we've got a lot of different, let's just say, influencing factors. So we've got air masses coming from different locations. That we have maritime tropical, right, warm and moist conditions coming from the Pacific, from the Gulf, and from the Atlantic. We have maritime polar, cool, moist conditions coming from the North Pacific. We have maritime polar that come from the North Atlantic. We have continental polar, very cold, very dry air coming from Canada. We have continental tropical, hot, dry air coming from Mexico and even into Texas. And we have continental Arctic, very cold, very dry air. So these are air masses. Air masses, they're just large bodies of air. Roughly 1,600 kilometers, right, or about 1,000 miles or more across. They're several kilometers thick. They have similar temperature at any given altitude, and they have similar moisture at any given altitude. In other words, their conditions are, let's just say at the like altitudes or elevations, are homogeneous. And these move and affect large portions of our continent. The source region, very important term here. The area where an air mass acquires its properties. So we have to look at, well, what are the properties? Essentially, we'd say, well, if is it continental or is it maritime? In other words, does it form over land or does it form over water? Continental, land, maritime, water. Is it polar or is it tropical? In other words, what latitude does it originate? If it's polar, it comes from the north, a northern latitude. If it's tropical, it comes from the south, or a more southernmost latitude. So the features of the source region is the area where an air mass acquires its property. Very key to making sense of air masses. We have to find out, well, where are they from? Because that'll determine what their conditions are. So if you look at the handout you have in your binder, you'll see that you'll have, let's just say, several different pictures in which you can make sense of. Right? It looks like this one here. So let's look at these. You can fill these out as you follow this. So here goes. So let's start off our winter pattern. It really doesn't matter if we're talking winter pattern or summer pattern, but we'll start off with our winter pattern. We have this maritime tropical, right? We have warm, humid air. So maritime tells me it's going to be humid, and tropical tells me it's going to be warm. So I have these maritime tropical conditions coming from the south. Whereas I can also have a continental tropical coming from the south. Continental tropical just tells me that it's going to be hot, right? Tropical, but it's going to be dry. So hot and dry. Continental, associated with dry. Maritime is going to be associated with humid. Let's go back to the picture here. So I have maritime polar. Maritime tells me that it organized or got its characteristics from a body of water. It's going to have the humid feature. And polar tells me it's going to be cool. I have continental polar, right? Cold and dry. Continental tells me dry. Polar tells me cold. But I can also have these polar vortexes, or these extreme, let's just say, conditions where the jet stream dips really far down south, and we have the continental Arctic, right? Small c, capital A. Very cold, very dry conditions. So the air masses, right? The source regions dictate the conditions or the properties that the air mass actually has, right? And in the summer, we have some different, we have the same groupings, but they just affect us a little bit differently. This is where we have maritime tropical coming into contact with continental polar. We have warm, moist, right, warm, humid air colliding with cool, dry air. And this is really the central plains are pretty much where they do their little dance, and that's how we get weather. So if I look at a cold Canadian air mass, farther north it's going to be extremely cold, and as it kind of marches southward, now it does kind of warm up, but it's still a very cold air mass. So if I look at this, right, in different locations geographically, as it's moving further south, it does warm up ever so slightly. And there's different conditions, different reasons for that. But if I look at lake effect snow, right, lake effect snow, it's telling me that I have a continental polar air mass that's moving southward from Canada, and it moves over Lake Michigan, or all of the Great Lakes. So Lake Michigan, or the Great Lake that you're looking at, provides both warmth and moisture for cloud development, right? So if you look at this, Lake Michigan is going to provide the conditions. It's going to provide the moisture that's going to rise and adiabatically, it's going to build up It's going to rise and adiabatically cool, and it's going to have the conditions then for snow. And the snow is going to take part on the leeward side of the lake, or the far side. So warmer air rises, right, condenses adiabatically, and snow results due to the cold atmospheric conditions, right? That's snow. As the continental polar air mass advances, it continues to deposit snow on the leeward side of the direction of the air mass is traveling. So I can look at this with a map. So Lake Michigan, notice as air comes from Canada, kind of at an angle, right? Lake Superior here, you see this dark region right here. They get large lake effect snow, large amounts, measured in feet of snow, lake effect snow. Notice east of Lake Michigan and even south of Lake Michigan, you always hear about Lake Michigan or Indiana being affected by winds coming out of the north, lake effect. But we're also in a lake effect zone. We get between, we can get a couple feet of snow, and that's not uncommon for us to get a foot of snow over the course of a year from lake effect conditions. We're close to the lake. Notice the leeward side is the far side, and they get tremendous amounts of snow. So the dark blue here. So lake effect snow is simply saying the cold air is traveling over the lake, and the lake provides the moisture, cools adiabatically, cold conditions, and you generate these tremendous snow, high density snow areas. And they're just consistent with the traveling over the warm lake. So air masses. So classification of an air mass. There's two criteria. By the latitude, the source region, right? If it's polar, it'd be a high latitude and it's conditionally cold. Tropical would be a low latitude and it has conditions of being warm. Where two other criteria that we can identify are the nature of the surface of the source region, and that's continental. Continental form over land and they are generally dry. Maritime, or small m, form over water, and these are humid. So continental is small c, maritime is small m. Polar is capital P and tropical is capital T. So we'll start putting these together here. So the nature of the surface in the source region determines what the air mass has. So in other words, there are four basic types of air masses. You have continental polar, small c, capital P. You have continental tropical, small c, capital T. You have maritime polar, small m, capital P. And you have maritime tropical, small m, large T. Here I can look at this map here. I've got cold conditions coming out of the north. I have warm conditions coming out of the south. Warm, moist air from the south, cold, dry air from the north. So, continental polar and maritime tropical air masses are the two most important air masses in North America, especially east of the Rocky Mountains. Continental polar, from northern Canada and the interior of Alaska. In winter, these bring cold, dry air. In the summer, these bring cool relief. These are responsible for lake effect snows. And that's what we went over here. Continental polar air masses crosses the Great Lakes, and they pick up that moisture from the lakes. The lakes provide the moisture, and then the snow occurs on the leeward shores of the lake. So let's take a look at maritime tropical. These are from the Gulf of Mexico and the Atlantic Ocean. These are warm, moist, unstable air. They bring precipitation to the eastern parts of the U.S. Continental tropical are from the southwest and Mexico. These are hot and very dry, right? Continental tells me it's dry. These are seldomly important outside of the source region, just that area, right? That's almost a desert region there. So maritime polar, small m, capital P. These bring precipitation to the western mountains. Occasionally influence the northeastern U.S. called the nor'easters, and in New England, with its cold temperatures and snow. And you hear about these, they make the news irregularly. When I go back and I start putting all these together, you'll see that these are the conditions back from slide 1. That if we find ourselves located right here, these are what we find. Let's just say we have continental polar from Canada, we have maritime tropical from the Gulf / kind of this southeastern region, that where they collide, we get weather, we get precipitation, we get severe weather, but we get the conditions that we are identifying based on what is happening with the air mass, and the air masses are simply a function or a result of where they form.